Welcome again. Oh, okay, you're recording the.
Oh,
Good afternoon, all. Thank you very much for attending this fourth session of 9 possible sessions in this training program that we are giving, that the South African Mathematics Foundation is giving to all students who are showing great hope in mathematics problem solving. You have been invited here because of your abilities in mathematics. So welcome once again. Without further ado, we want to go on to the matter at hand. All right. So I would be feeling my duty if I don't welcome once again my good friend David Ramaboka of South African Maths Foundation, who will be assisting me uh, in administering this session. All right, let me go straight to my. Okay, so we go to senior session 4. Right, the first problem is this. Okay, let me. Yeah, I just had to open up a Word file. The first problem says. Sorry about this. What's going on here? Okay, now can you all see the screen?
yes, I can see the screen, Prof. Yes.
All right. Okay, so what we have here is the problem which says 3 carpets have a combined area of 200 square meters. What does that mean? It means that if you place those carpets side by side, totally the entire area will be 200 square meters. Just remember that. By overlapping the 3 carpets, like the way the diagram shows, you got one carpet on top of the other. Then the total area that is covered is 140 square meters. Okay, that's understandable because now you've got a lot of carpets which are sitting on one on top of each other, and some of the area is being reduced. Now, the area which is covered by exactly 2 layers of carpet is 24 square meters.
Okay, let me just go quickly check if my password is to be reset.
Somebody's chat is open. Please mute so that we don't have any interference. Okay, so what we've got here is we don't know what area there is covered by each carpet, but if you look at this, you will see that this part here, the P, is the area which is covered by just one carpet. Only this carpet here covers that. And here again, the Q is 1, and this is 1. But the A part, both 2 carpets are covering the A part, and the same thing with B, the same thing with C. And this part here, X, The question is, what area of floor is covered by exactly 3 layers of carpet? So I've given the name of X to that because we need to find X. This part here is covered by 3 carpets. So now how do you go around doing this? It looks like a very difficult problem because you've got so many unknowns. So maybe we'd better give names to the area that is covered by different parts. So let's see, the area covered by 1 carpet. Let A be equal to area covered by 1 carpet. So that is equal to P plus Q plus R. You can see those are the 3. So A is equal to P plus Q plus R. Okay, and then the area covered by 2 carpets, we'll give it a name B, and that is A plus B plus C. See, there's so many unknowns, so we might as well try to kill the unknowns by replacing several of them by a single one, like what I'm doing now. So I've now reduced the problem to just 2 unknowns, A and B, and you've got 6 symbols are used here. And altogether, we've got 7 symbols here. So the only other symbol which hasn't been used is X. All right, now let's see. With this information, can we get some equations? The area covered by 3 carpets have a combined area of 200 square meters. All right, so that is actually, so the area covered by 3 carpets is, you're going to add up all these and X, that's the first carpet, all these and all these. So in other words, we're adding 12 numbers here to get 200, all right, if you separate them. So we can, how do you get those 12 numbers? So what actually happens is that you've got P plus Q plus R. That's the area covered by 1 carpet. But now here, this A is counted twice, you see. And so is B and C. So you really have 2 into A plus B plus C. Because this A is counted twice when you separate them. And the same thing with C, and the same thing with B, and then finally X. Okay? So that gives you, this area here is 200. The total area. Oh, you're supposed to have 3X. That's right. Because X is counted twice. Sorry. So here we're supposed to have 3X. That's 200. I've given a name to this thing here, so let's call it A plus 2B plus 3X is 200. All right, so I've used the first piece of information. The second piece of information says that by overlapping the 3 carpets to cover a total area of 100 square meters, so 140 square meters. So this area that we are seeing here is 140 altogether. Now that is the P plus Q plus R, which is your A, area covered by 1 carpet. And now it's A plus B plus C, because this is the area that we are looking at. So that will be B and then X. So the area covered by this entire piece here is 140. And then it's also given here that the area which is covered by exactly 2 layers of carpet, in other words, this part here, that part there, and that part there, the area covered by those 2 layers of carpet. So this area plus this area plus this area, in other words, A plus B plus C, which we've given a name to already. So B, which is equal to A plus B plus C, that is the area covered by exactly 2 carpets. And it's given that that is 24. Okay, so that's fine. Now you got 3 unknowns. Actually, you've got only 2 unknowns because B is given. So if you look at this, you will see, let's substitute for B. B is equal to 24. So that's 48. A plus 3x. So this part here is 48. 200 minus 48, you bring it to the other side. That gives you 152. And I'm going to substitute 24 for B here and take it to the other side. So A plus X survives on the left-hand side, and the 24 is taken to the other side. 140 minus 24 is 116, I think. And then now you've got 2 equations and 2 unknowns. You can solve for X, right, by eliminating A. And how do you eliminate A? You just simply subtract, because you've got A and A on both sides. 3x minus x is 2x. And when you subtract these two, you get 152 minus 116. And that is 36. So 2x is equal to 36. So finally, you have x is 18. And that is the area which is covered by exactly 3 layers of carpet. I should have said x is equal to area covered by 3 layers. And that is what we needed to find. Quite a nice problem. Although there are 7 unknowns here, we were able to solve the problem by simply giving names to groups. Okay, so let's get on to the next problem. All right, so you got this problem here. Let A, B, and C, A, B, and C are positive integers. Okay, that's very nice. In other words, they are 1, 2, 3, 4, and so on. We've seen quite a few problems like that now, where the symbols are not random real numbers, but they are positive integers, very, very specific, such that ABC is equal to A plus B plus C. So when you multiply these 3 numbers, you will get this equal to the sum. Yeah, that's quite interesting, because when you multiply, you're going to get much more than adding. So the question is, now if you multiply 3 numbers and it's the same as adding them, what are the possible values for A, B, and C? They actually asking what is A plus B plus C. Right, now this is an interesting problem, because there's a strategy here which you will see that not many people will be aware of this strategy. So I want you to listen carefully, because why are we? Yeah, so what we have here is, you see, the way this equation is structured, it doesn't really matter if you mix these A, B, and C around. By that I mean, if you replace A by B and C by A and B by something, you'll get exactly the same equation. That requires a little bit of insight, but you can see that you can what you call permute. If you put in place of A, B, C, I'll put B, C, A. Then I'll put B, C, A, and A is B, and C is B is C, and C is A. So you get B plus C plus A, which is the same thing. Now, why do you say all that? Because in this particular problem, I'd like to assume that A is less than or equal to B, less than or equal to C. Right. I'm going to assume.
Hold on. I have to.
Somebody, Lefa, would you please put your speaker off, because you are speaking and we can hear you. So I'm going to make an assumption like this, and I'm allowed to make this assumption because of what I just said earlier, that it doesn't really matter how you split them around. So you can make this assumption that let A be less than or equal to B, less than or equal to C. All right. Now, given that, now this means now then, the important fact, C is the largest and A is the smallest, so A over C is less than or equal to 1, because C is the largest of this of the three numbers. So when you take the ratios, you're going to get this is less than or equal to 1. Now, why do I need that? Because I want to take this equation here, A, B, C equals A plus B plus C. And I'm going to use this fact here that A over C is less than or equal to 1. And how do I use that? To do that, I have to divide right throughout by C. So let me divide on both sides by C. You'll get AB on the side. And here you'll get A over C plus B over C. I'm dividing each number by C. And C over C is just 1. So I divide both sides by C, and this is what I get. And now the nice thing is that this guy here is less than or equal to 1. So this is less than or equal to 1. The second one is also less than or equal to 1. So the entire right-hand side is less than or equal to 3. Now, that's quite a powerful statement that we've arrived at. That the product of A and B, AB, is less than or equal to 3. See? And the starting point was to order them in increasing order like this. Very often you use this strategy, especially when you got equations which look like this. Then you can order them. You can say something is the smallest, something else is the largest. We'll come across other problems like that. So just bear in mind that strategy. So now you've got the product of two positive integers is less than or equal to 3. So what are the possibilities? You can have AB equal to 1, right? Okay, is AB equal to 1? Let's just see whether that is so. All right, if that is so, if so, then the only way you can have two positive integers having the product equal to 1 is that both of them must be equal to 1. See, we're working with positive integers. That's a powerful statement. So the smallest possible, the positive integers are 1, 2, 3, and so on. So if A and B are both equal to 1, and if you go back to this equation here, right, and if you substitute A and B both equal to 1, what do you have? 1 times 1 on the left-hand side. And here you've got 1 plus C, which is 2 plus C. And you got C is equal to 2 plus C. If you have A and B both equal to 1. Obviously, this is impossible because this is strictly greater than C. It can't be equal. Another way of looking at it is, then if this is true, then 2 equals 0, which is ridiculous. So this cannot be. So what happened now? Why did we come to something which is impossible? It's because we assume that AB can be equal to 1. So therefore, this assumption is false. Right? So AB is not equal to 1. That's the conclusion. All right, so the other possibility, the next one is AB equal to 2. So is it possible that AB is equal to 2? Well, A times B equals 2. Remember, we said that A is smaller than B. So if the product is 2, then A must be equal to 1 and B must be equal to 2 because A is smaller than. So now you have that A equals 1, B equals 2. And with that information, is it possible to calculate C? Let's go back to the master equation, which said ABC is equal to A plus B plus C. So if A equals 1 and B equals 2, then you got 1 times 2, just 2C on this side, and that is equal to, now here you get 1 plus 2, and that is 3 plus C. All right, so you've got 2C is equal to 3 plus C. I've substituted for A and B, got rid of 2 unknowns. So I've got just 1 unknown left. If you bring the C to this side, 2C minus C, the C is equal to 3. Okay, now this is quite possible because C is the largest. So let's see. So this allows you to say that therefore C is equal to 3, right? And let's just substitute that and see. Now you'll have 1 plus 2 plus 3, which is 6. And 1 times 2 times 3 is 6. Oh, that's fantastic. So this is a solution, right? And the A plus B plus C, then A plus B plus C is equal to 6, right? A, B, and C are equal to 1, 2, and 3 respectively, right? But there may be some other solutions because we still need to have a look at what happens when A, B is equal to 3, right? Okay, maybe this will give you another solution. Once again, you got the product of 2 numbers is equal to 3, and A is smaller than B. So here you will have A is equal to 1, and B is equal to 3. That's the only way you can have this product equal to 3. So let's go back and substitute it into the master equation. We've got two unknowns have been found. So you can substitute it. Always, whenever you find an unknown, one, substitute it as quickly as possible because you want to get rid of it. That reduces your unknowns. So you substitute it into your equations, and that will get quickly to the solution. So A is equal to 1, B is equal to 3. So here you have 1 times 3. And here you have A is equal to 1, B is equal to 3. A plus B is 1 plus 3, which is 4. 4 plus C, okay, that's fine. And then you have 3C minus C is equal to 2C equals 4. And therefore C is equal to 2. Right, so that's fine. Here you can have C equals 2. But wait a minute. We said that A is less than B is less than C. So now how can C be equal to 2? That C has to be larger than B. So this is not possible, right? It's out. So AB equals 3 also gives you an impossibility. AB equals 1 gives you an impossibility. So there's only one solution, right? So this is the only solution. So it's an interesting problem because you've got only one equation with 3 unknowns. And you might say, hey, wait a minute. I've got 3 unknowns. How can I solve for them? See? And that's a nice thing about working only with positive integers, or integers for that matter. But positive integers is even better because it's a very strong constraint. It allows you to make all these conclusions. AB is equal to 2. You can say exactly what A is and what B is. See? Normally, you can't do that because A could be half and B is equal to 4. So half times 4 is 2. So, but those are not, it's not allowed because we're only working with positive integers. Okay, so let's get on to the next problem. Okay, so the next problem is this one. Okay, it looks like an area problem. 2 squares, A, B, C, D. Well, let's see, A, B, C, D. Okay, so the large thing is a square, and B, E, F, G So this white thing is also a square. So both of them are squares. They share the vertex B. All right, you can see. B is a vertex for both squares. With E on side BC, so E is here, and G on side AB. You see, normally the diagram is not given. So that is why all these descriptions have to be, with this description, you should be able to draw the diagram. But in this case, I'm not sure whether the diagram was given in the actual question, but I've given the diagram anyway. All right, so you have to draw the diagram like that, using the information. The length of CG is 9 centimeters. So we are told that CG is 9 centimeters. This part here is 9. Let's record that. CG equals 9. And the area of the shaded region, also they did give the diagram because there's a shaded region, is 47 square centimeters. Oh, now this is a very funny looking shape here. We need to have an equation to create that 47. All right, now how do we do that? Well, for one thing, the area of the shaded region, we don't know what it is. Well, we know what it is, it's 47. But when you add it to the white area here, you're going to get the area of the entire square. So that's fine because we know the area of the white square and we know the area of the large square, provided we know what the sides are. They are squares, so there's only one dimension, namely the side. If you know the side of a square, then you know everything about the square, you know the perimeter, the square, and so on, the area, and so on. So we don't know what it is, so let's give a name to that. And even this one, the large square, let's give a name to that. So now we are giving names to the sides of the two squares, the large one and the small one. And now, given that now, we should be able to create an equation with this. The length of CG is 9 centimeters. All right. Okay, now that's interesting. CG is the hypotenuse of a right angle triangle, right? And do we know the other two sides? The answer is yes, because if this is y, it was given that this is a square, so all the sides are equal. So one side is y, and the other side is this, and we just called it x, the side of the large square. So you have a right angle triangle. The hypotenuse is 9, and the two sides are x and y. So you have an equation. See, the whole idea in problem solving is to get to equations. Every time you create an equation, simultaneously at that time, there should be a smile playing on your face, which says that, I'm getting there. All right, so this is happy, the happy moment. I think these mojos, something like that. So you got x squared plus y squared is 81 using the theorem of Pythagoras. All right. Okay, so we just used the 9 to get an equation, but now we still need to use the equation 47. This thing here should have been square here. So you got 47. Remember, 47, that's the yellow part, plus the white part. The area of this here is y squared. So if you add the shaded part plus the white part, you're going to get the area of the whole square. And the side of this whole square is x squared. So the area of the whole square is x squared. Okay. So again, you have another equation in x and y. So let's just bring all the x's and the y's together. I'm going to rewrite the first equation. And the second equation, if you bring the y squared to this side, you'll have x squared minus y squared. And you take it to that side, equals 47. So I'd like to bring all the unknowns to one side. But it's on the left-hand side or right-hand side, doesn't matter. But if you bring it to the right-hand side, just remember that you have to write it underneath this. So now the question is to find the perimeter of the shaded region. Okay, this perimeter here, the entire that plus that plus that plus that plus that plus that. Okay, so we need to work out the two unknowns, x and y, and we already have them here. Because now you've got two equations, the two unknowns. When you add them, you get 2x squared. The y squareds cancel, is 181 plus 47 is 128. So x squared is 64. If you divide by 2. I just want you to observe something. The perimeter of the shaded region, now listen carefully. If I start now, I can go up here, go up there. Okay, I'm hitting the side of the large square, hitting the side of the large square. And here, I'm hitting part of the side of the large square. Right. But I need to add these two pieces. But observe that this piece is also y. Right. So I need to, and this part here is also y here. So the perimeter is that plus that plus that plus y plus y. But plus y, you can go along this. And you come back to your starting point. Right? And I'll repeat that. You go up, go up, go up, go up. And instead of adding that, it's the same as adding this. And instead of adding that, it's the same as adding that. So it means you make a one traversal right round the large square, and that is the perimeter of the shaded square, right? So the perimeter of the shaded square. This is a trick. I've seen it elsewhere in other Olympiads, where it looks as if you got a funny looking shape, but with a little bit of thought, you can tell yourself, well, let's take this thing here, cut it and paste it here. Or take this and cut it and paste it there. Then the perimeter now just becomes the perimeter of the square. And the perimeter of the shaded square equals the perimeter of the large square. That is the moral of the story. And the perimeter of the large square, the side is x, so it's 4 times x. And we just calculated x squared. So x is equal to 8, because x squared is equal to 64. So x squared is equal to 8. I mean, x is equal to 8. So the perimeter is just 4x. This is just an extra observation. You could have added y and do all that, make those calculations. But it'll take a little bit of longer time. But you still come to the same answer. But there's a little bit of insight that I've given you that you can work on the perimeter very quickly by making us an interesting observation. Okay, so let me get on to the next problem. Okay, let me just take a little break. If you got any questions, you can put it in the chat column. I'm going to look at the chat column and I see there were some people who came in late. I asked those who came in on time to write in the chat column on a scale from 1 to 10, how useful these lessons have been. You've had 3 sessions so far, and whether you learned a lot or you find you think it's too hard or whatever. But give me a rating from 1 to 10. 1 is very bad, and 10 is you learned quite a lot and you found this very useful. So you can go to the chat column and fill that out. I won't look to see who's doing what, but if there are any questions that you want to have, you can put that in the chat column as well, and we can address this at the end of the class if we do have time. All right, so let's get on with the work at hand. So the next one is how many integer values, in other words, you're allowed to have positive and negative integers are there so that the square root of n minus 2n squared plus 15 is a real number. Right. So that is okay. I'm trying to do something here, but it's not helping. Okay. Now, what do you mean by saying the square root is a real? Oh, yeah, it's a real number. When is the square root not a real number? So let's just find the thing out. The square root of a number is not real, otherwise you cannot find it. It doesn't exist. When, like square root of -1, that's it, you can't find it. The reason is that the square root of a number, if it's x, then it means that x times x is equal to, if this is equal to x, then it means that x squared, x times x equals -1. Now this is impossible because if you multiply a number by itself, if it's positive, then both are positive. So the square, this product is positive. If x is negative, then both are negative, and the product will again be positive because they are negative times negative is positive. So it's impossible to get -1. So therefore, you cannot have the stuff inside the square root sign in general cannot be negative. So to say it cannot be negative is the same as saying that it is greater, it's either 0 or it's positive. Right. So the answer to this question, to get to the answer to the question, you're asking the question, for which values of n, find n so that this quantity n minus 2n squared plus 15 is greater or equal to 0. Now you do this in school. This is one of the few times where an inequality that you do in school occurs in problem solving. So, but the only difference is that, say, what are the integer values? Okay, so we want to solve this inequality, and I got -2n squared here. I want to bring this in the form of a quadratic. Because we can solve a quadratic inequality. That's one of the things that is done in grade 11 or 12. Well, not as far as 12, but grade, no, you are seniors, right? So grade 10, I presume that you would have done this, a quadratic inequality. Okay, we'll just see how it's done now. But I don't like a negative sign in front, so let me change the signs. But to change the signs is the same as saying that, when I put this means it's the same as saying that when you you have to multiply on both sides by -1. That is what changes the sign. Don't just say changes the sign. This is, it doesn't give you too much information as to what you are doing mathematically. But what you are really doing is multiplying this on both sides by -1. A very important fact, whenever you got an inequality, and if you multiply it by negative on both sides, right, the inequality changes. Like 3 is greater than 2. Well, actually, it's greater than 2. If you multiply by -1, right, you don't have -3 is greater than -2 because -3 on the number line is on the left of -2. So this -3 is smaller than -2. See? So whenever you multiply anything by a negative, the sign changes. So I had positive here. So this sign here I should have had negative. Right? So this sign now changes to less than or equal to. Now, how do you solve a quadratic inequality? Well, the easiest way is to factorize it. Now, I'm not going to go and factorize this thing here in the long way. I can see mentally that I think it's going to be so we have n. If you multiply this, I think you're going to get minus 6n plus 5n, yeah. All right. So you got the product of two numbers is negative. And so what can you say about these numbers? So you'll have to have one of them is positive and the other is negative. So I prefer drawing a graph of a quadratic minimum value. The a is positive. It goes like this, and the roots are 3 and minus 2.5. So you get minus 2.5 is an intercept of this graph, an x-intercept, and 3 is also x. The variable is n. So this is n on the side. And the graph of this is, it's got a minimum value because the a is positive. So it comes down like this. Inequalities are, I always do it by graphs. It's so easy. So you want to know for which values of n is this negative? You can see it's going to be negative for all these values of n. Outside that, it's positive. So what are these n's here? You're looking for integer values. So what are the integers between minus 2.5 and 3? The integers between negative 2.5 and 3 are, so you look at all the integers here. So negative 2.5 is not an integer, but negative 2 is one of them. Negative 1 is one of them. And 0 and 1 and 2. And you're allowed to equal 0. So you can include 3. If this was strict inequality, then you're not allowed to include 3. Okay, so just to recap, the quadratic inequality, and this is called a quadratic inequality because this is a quadratic function. It's got a square and something like, it looks like ax squared plus bx plus c. Now that's called a quadratic function. And this is an inequality. It's not a quadratic equation. The equation, it'll be equal something. But here it's less than or equal to, so it's inequality. It's called a quadratic inequality. The nicest way to solve this is to draw the graph of that. And hopefully you know how to draw the graph of these things very quickly. All you have to do is to see whether it's got a minimum value or a maximum value. And you see where it cuts the x-axis. And you can see where it cuts the x-axis very quickly by looking at the roots of this. N equals 3, the value is 0. N equals negative 2.5, the value is 0. So it cuts the x-axis, is minimum value, so you can quickly draw the graph without bothering about what the minimum value is, because we're only interested to know for which values is this thing negative, and it's between these two, right? If it's positive, then you can say n is greater than 3, or not and, or n is less than that, because you can't have anything which is greater than 3 and less than that at the same time. That's impossible. So you have to say or. Okay, so the question was how many integer values? You must answer the question. There are 6. There are 6 integers that will satisfy this inequality, and these are the 6 integers. If you substitute these numbers, you're going to see that all those numbers are real. Okay, so that now takes me to the next problem, which is this one. All right, now we are getting on to the real meaty stuff. People are usually very scared when it comes to problems, so-called word problems, right? I just call them problems. Word problem means you're describing an event like what we are looking at on the screen here now, right? Um, Amongst the word problems, you have these so-called distance time problems. And I know that a lot of teachers even skip this thing because it's not easy to teach. So we're going to have a couple of distance time problems. And you have to have a clear mind on this thing. You have to imagine the whole thing and get a proper understanding what's going on, and then do it step by step. All right. So let's get going with this first problem. A racing car is going around a track that is a square 1 kilometer on a side. Right. Now, as always, you know, by now I don't read the entire problem. As we read them, I enter the information. So I got a square, right? 1 kilometer on a side. So the square is, each side is 1 kilometer. One. Right. Now, if it goes at an average of 60 kilometers per hour on the first two sides, all right, we don't know where it starts, but suppose it starts here, and it's going down like this maybe. Okay, so the first side it travels down is, so you start. This is the first side. It's traveling at 60 k's per hour. The second one also, the first two sides, 60 k's per hour. And 90 kilometers on the third side. On the third side, how fast must it go on the fourth side? So this is not given. It's unknown there. On the third side, to average 60 kilometers all the way around. Right? To average 60 kilometers per hour all the way around. I can tell you that many people will do it like this. They say, okay, if you want an average of 60, it means if I call this fast, so it's a speed. Usually you use the symbol V for speed, right? V is velocity. But instead of using speed, we put V, because the reason is in physics, you have S is for something else. I can put S, but S is for so-called displacement. So in general, I just use the symbol V for speed. So most people will say, well, this is easy, right? To find the average, if the average is going to be 60, that means V plus 60 plus 60 plus 90. Take the sums of all the various velocities. To find the average velocity, you add the four velocities and divide by 4. And that is going to be equal to 60. And then you can work this thing out. This is V plus 210 is equal to 240. So V equals 30. Most people will do this and they'll sit back and smile and say, well, I've solved the problem. I know what average is, so I've solved the problem. The sad part of this is that this is wrong. You don't do it like this. You see, you have to integrate what do you mean by kilometers per hour and what do you mean by average speed. Right. To say average speed is 60, that is not the same as saying the average of the speeds, right? Whenever you're talking about a speed, it's usually the average speed. When you say this vehicle is traveling at 60 kilometers per hour, it is not traveling 60 all the way, guys. At the start, it's 0, right? when you say 60, it means this is the average speed, right? When you add up all the speeds right throughout, you say the overall speed is 60, right? So whenever we say a vehicle is traveling at 60 kilometers per hour, whatever, it is the average speed, okay? And the formula for an average speed is distance over time. Now, this is extremely important formula in all these things. In fact, it's the only formula. Distance is equal to speed multiplied by time. Right? I mean, it should be obvious. If I'm traveling from Durban to PMB, for instance, and I travel at 80 kilometers or say 40 kilometers per hour, okay, at my age, this is the average speed I will travel. And the distance to Pietermaritzburg is 80 kilometers. It'll take me 2 hours to get there. Now, how do you get the 2 hours? It's this distance. In 1 hour, the kilometers per hour means in 1 hour I travel 40 kilometers. So how many hours will it take to travel 80 kilometers? The answer is 2. That's obvious, right? But if you look at that, it means that what I'm doing is I'm actually taking the distance and I'm dividing it by the speed, and that gives me the time. 80 divided by 40 gives you 2 hours. So the formula is distance is equal to the speed times time. So that is where you get this. So you can have distance divided by speed is equal to time, or distance divided by time is equal to speed, and so on. All this is quite obvious, but it's nice to put it down in the form of mathematical equation so you understand what the process is in this. So this thing here is wrong because the average speed is the total distance divided by the total time. So the question says, what is the average speed for the entire way all around? So the average speed will be the total distance you travel all around is 4. It says all the way around, right? That's your distance, divided by the time that it takes to travel. Now, we know the time. Well, we don't really know the time. What we do know is that it travels 60 kilometers per hour. This 1 kilometer in 1 hour, the car travels 60 kilometers. So 1 kilometer would be 1 over 60 hours. Right. That's what it is. It's distance divided by speed is the time. So the time taken to do the first lap is 1 over 60. And the time taken to do the second side of the square is also 1 over 60 because that distance is 1, same speed. Here, the speed is a little bit more. So the 1 over 90, so you can see it takes a shorter time because it's traveling faster, right? It's traveling 90 Ks. So this is smaller than that one. But you still got this last part, which is, this is your unknown is your V. So it's 1 over V. We don't know what this is. And that's a thing you have to calculate. And this average speed is given that the average speed is 60. So this quantity here is 60. Not what I told you earlier, that you add the four velocities, 4 speeds, and divide it by 4. So it's a little bit tricky. So here you have to calculate the V. And I don't know whether I should calculate it. Okay, so you have 4. Let's multiply on both sides. So you have 60 times 1 over 60 is 1. 60 times 1 over 60 is 1. Here you have 60 over 90 plus 60 over b. 4 divided by this is that, so therefore your 40 is 4. So that is equal to 60 times that. Now 60 times, I'm multiplying each one of them. And I can calculate this thing. I don't know how long it will take me, but it's 2 plus 2/3, which is 8 over 3. Plus 60 over b. So 60 over b is equal to, this is just calculation. I'm not going to waste my time too much. It's 4 over 3. So therefore b is equal to 45. 60 over 45 is the same as 4 over 3. And that is a long distance from 30. Earlier on, we said it's 30 kilometers per hour. It's actually 45 kilometers per hour. You have to travel at 45 kilometers per hour here to get an average of 60 kilometers all around. So that's the answer. You have to put kilometers per hour. Observe the units are always make the same units. If you're using kilometers, stick to kilometers. Hours, stick to hours. Sometimes you might have to change the units from hours to minutes. I think some of these problems that we're going to do will deal with those. Okay, so let's just get on to the next problem. All right, so this is an interesting problem where we use distance is equal to speed times time very effectively. And we see that it's not so trivial. Okay. Let's get on to the next problem. The next problem is the following. Athletes A and B run at constant speeds in opposite directions around an athletics track. All right, now we don't know. Okay, let's draw the track. All right. Now, the tracks are usually kind of circular or elliptical or whatever. Let's just draw. Oh, I can draw a nice ellipse here. Okay. Right. I think it's elliptical. All right, so you got these guys now. They are traveling at constant speeds in opposite directions. Oh, all right. So what happens here is that they begin at the same time from the same point. Okay, that's useful. So they're both of them at a certain time. They are together. And then one guy travels this direction. Let's say that there is A. And the other fellow travels in this direction. Right? He's B. All right. So obviously, they're going to meet somewhere, traveling opposite direction. Or they're going to cross each other. Right? Now, given here, for every 2 laps that B completes, so this is a lap. A lap is one right round. Right? Every time B completes 2 laps, A completes 3 laps. So A is obviously faster. Right? A is faster. And B is 2 laps. Now let's just interrogate that. If you think of that, you will see that means A is traveling 1.5 times faster than B. Because B, when he does 2, this guy does 3. So he's traveling at 1.5 times that of B. Okay, so I want to know when they cross. So let's see what happens. When do they first meet? That's an interesting question. When do they first meet? So A, if he covers, he's faster. So you'll probably meet him here somewhere. Right? This is where they meet. Now, how much this distance here will be 1.5 times that distance. right? Because he's traveling 3 laps while this guy travels 2 laps. So, but the best way to look at it is that this part here, if it's 3 parts, then this part here is 2 parts, right? Of a lap. So we are talking about lap here. So let's see, how much of a lap does he cover, right? A lap is a full distance he travels around this track. Okay, so A would have covered 3/5 of a lap, because A would have covered 3 parts and B covers 2 parts, and altogether you have 5 parts of a lap, and A will cover 3 parts of that, so you'll cover 3/5 of a lap, while B covers 2/5 of a lap, and that is where they first meet. So this is the meet one. Let's call it meet one. This is where the first meeting point. Right. Now they continue. A carries on, and B carries on, and they keep going like this, and they will meet like this several times. So the question there is, how many times do they pass each other when A has covered 10 laps? Right. In other words, A has covered 1, 2, 3, and so on. That looks like a very difficult problem. But there's a very, very cute way, a very nice way of doing this thing. You see, when they meet, it's like they are starting all over again. It's like a replay of what went on here, but starting at this point. See, here they're starting together and they go in opposite directions. Here too, they are together and they travel in opposite directions. So it means that A will continue to, the next meeting point is when A covers another 3/5 of a lap. So A will carry on and come to 3/5 of a lap. And this is the meeting point, meet 2, will be, this will be that, from there to there will be 3/5 of a lap. A will cover, and in the meantime, B is traveling slowly, he will cover another 2/5 on that side of a lap. But I'm interested in just A now. So they meet. I'm going to say this now. They meet. And this is what I said earlier on, that you have to understand the problem, get a feel of it, right? And then you have to think. You just don't have any equations and solving equations, right? It's not like that. Okay, they meet whenever A covers 3/5 of a lap. Each time they meet, you cover 3/5. So, in other words, after the first lap, this is, they meet at 3/5. This is the point here, and then he travels another 3/5, and then he goes 3/5 of a lap, and he keeps finishing 3, and all these are meeting points. Meeting point, first meeting point, second meeting point, third meeting point, and so on, right? So you want to know how many meeting points are there. When A covers 10 laps, so A will have to cover, altogether A covers 10 laps. See, it might be easier to visualize this thing as though you're not traveling along an ellipse, but you are traveling along a kind of a straight line, right? And then in that case, what you've got is, there's your starting point, start, and then after 3/5 of a lap, they meet once, another 3/5, they meet again, and so on. And each one, so you want to know altogether, if you got 10 laps, how many 3/5 are there? So the question arises now, how many 3/5 are there in 10? See, that is the question. Because we're adding all these, and you want to, there'll come a point when it's just below 10, And then after that, they might cross their original meeting point, the starting point, again, and meet again after that. But I want to know how many. So in other words, how many multiples of 3/5 are there in 10? Right. So if they meet 10 times, if they meet n times, then n is a larger, oh, let me. I just want to go into, I wiped out everything. Anyway, I do remember what happened. I just want to share the blank screen because I've run out of space. So where is this? Anyway, sorry about this. So I wiped out everything, but I'm going to recall what I have said. So the question is, how many 3/5 are there in 10? Or otherwise, what is the largest value n is the number of meeting points, number of times they meet. What is the largest value of n such that 3/5 plus 3/5 plus 3/5, the last time they meet, before they cover 10 laps, n of them is less than or equal to 10. It need not be equal to 10 because the next 3/5 they might cross the starting point. So you've got, this is n times 3/5. So that is 3n over 5 is less than or equal to 10. 3n is less than or equal to 50. So you see n doesn't go exactly into 50. So n is less than or equal to 50 over 3, which is 16 2/3. And n is a counting number, you see, because it's the number of laps. So therefore, the largest number, counting number, is, answer is 16. Because the largest, so they don't, on the 17th one, they will meet after they finished, they cross the starting point. Okay, so you can just think about that. The main thing is, what is the last time they meet, right? And that is the number of times you can count them, and then it's the number of times 3/5 must be added to itself to get 10. You don't get exactly 10, but it will be the highest value, which is less than 10. Think about that. It's a little bit tricky, but it's not that difficult. All right. So now we go on to the next problem, which says that a loaded truck travels from Durban to Pietermaritzburg at average speed of 60 kilometers after unloading and returns for the same route at an average speed of 90 kilometers per hour. What is the average speed of the truck on the whole journey? This is very similar to the earlier problem. I'm not going to spend too much of time over this because I'm going from Durban to Pietermaritzburg. I don't know what the distance is. So on the upward journey, it's traveling at 60 kilometers per hour. So therefore, it takes d over 60 hours. On the return journey, it travels at 90 kilometers per hour. So it takes d over 90 hours. we've done a similar thing before. So the total time that it would have taken is that, and the total distance it would have traveled is 2d, because it goes up and comes down, and that total distance over total time will give you the average speed. Right? And it turns out that the d's cancel, right? You can see you can multiply on numerator and denominator by 180. If you multiply this by 180, you get 3D. If you multiply this by 180, you get 2D. So you get 5D and so on. I think you get 72. I think. Right, so it's 72, and as I said, it's not 60 plus 90 divided by 2. Right? You have to do it like this. The total distance over total time is the average distance. Just remember that. Right? The average speed. That is what you mean by average speed. Okay, so we go on to the next problem. I rushed through that last problem because the next problem is going to take a bit of time. Right? Hopefully I can finish it in good time. Originally I had this as your homework problem, and then I realized, oh my God, this will kill you because it's quite a difficult problem. So out of compassion, I've changed this, your original homework problem, to something else. But bear this in mind, this is not your homework problem. Your homework problem is, you'll see it just now. It is another problem from session 4, the same session, but it's not the original problem that we had. Okay, now you got a long story here. A truck starts from point A towards point B. Okay, I've drawn it here for you. So it's truck, there's your T, truck, it's moving towards B. At the same time, a car starts from point B. So the car starts from here, right, towards point A. So now they are traveling along AB, and one goes towards B and the other goes towards A. Then you see when the car was halfway between A and B. Now there's your halfway.
Prof?
Yes,
Prof,
sir.
we can see that blank page.
I'm sorry. Are we not sharing?
Go back to the PowerPoint to share the PowerPoint.
I can't hear you, David. Can you see the screen?
Yes, but the blank page, you know, not what you were reading. Oh.
David, can you just make yourself a little bit louder? I can't hear you.
No, I was saying I can see this blank page. The other side of the page, not what you were reading, the PowerPoint where you are reading.
Or you can see a blank page.
Yes, not the PowerPoint.
Okay, so let me share then.
Yes.
I thought I was sharing. I'll stop share first, and then I'll go back to my PowerPoint. All right, now can you see it?
Yes, now I can see.
Okay, thanks very much for that, David. I wouldn't have known otherwise. Thank you very much. Okay, so let me repeat what I said. You've got a truck which starts from point A and going towards point B, and a car is going the other direction. And it is said here that when the car is halfway between A and B, so this point here is, as you can see, it's about halfway between A and B. When the car is here, what happens? So when the car is here, when the car is halfway between A and B, the truck has traveled exactly 1/3 of the distance between the two vehicles at that moment. So The distance when the car is here, the distance between the two vehicles, the truck, by the way, is already moved on here, and it's here somewhere, right? And the truck has traveled, the distance between the two vehicles is that, right? And the truck has traveled exactly 1/3 of the distance between the two vehicles at that moment. I could have called this x and called this x/3, which is 1/3. The truck has traveled 1/3 this distance here, but I don't like fractions, right? Although I see fractions later on, but I try to avoid them as far as possible. So it's better to call this distance the truck traveled x, then this would have been 3x, right? So that way we can say that the truck has traveled 1/3 the distance between them. So therefore, this distance here from A to the midpoint of AB is 4x. So this part here is 4x. So we got this picture here. The truck has traveled x kilometers, and at the same time, the car has traveled 4x kilometers. We are talking about at a certain time when the truck is at these 2 points here. So when the truck has traveled x kilometers, the car has traveled 4x kilometers. So what does it mean? It means that the car is traveling 4 times the speed of the truck. That's a very important observation. We saw earlier on too, we did something like that when we went around the lap problem. So there A was traveling at 1.5 times the speed of the other fellow. So here is the car travels 4 times the speed of the truck. So whenever the truck covers a certain distance, the car travels 4 times the distance, right? Because they are traveling at the same constant speed. Okay, so that's where we are now. After 36 minutes, the car and the truck met each other. So now, so they continue on their journey. So this car, it's going like this. And from this point here onwards, they both meet. Right. And this is after 36 minutes. Right? Both travel for 36 minutes. But what's interesting is that this distance here, which is 3x, it is now divided in the ratio 4:1. Because this fellow has traveled 1 unit and this guy has traveled 4 units. So altogether you've got 5 units. So you have to divide, you have to see where they meet. They meet when the ratio of the distances that they have traveled is 4:1. So in other words, you got 1 unit this way, you got 4 units this way, there are 5 units altogether. So this truck would have traveled the whole distance 3x/5. That's what I got here, right? And this is 4 times. The speed of the truck will be 3x. I mean, the distance a truck traveled is 3x/5, but the car would have traveled 4 times that. So you can see that's 12x/5. And if you add the 2, you'll get 15x/5, which is 3x. And that's exactly what we want. We're dividing 3x in the ratio. We're dividing 3x in the ratio 1:4. Whenever you're dividing something in a certain ratio, if you're dividing 20 in the ratio 1:4, then you will say 1 is 1/5 of 20, which is 4, and the other is 4/5 of 20, which is 16. And that is, you got 4 and 16, and that is 1:4, and they both add up to 20. Right? So that is how we get 3x/5 and 12x/5. So what does this mean? It means that this truck, the car has traveled 12x/5. They meet at this point here now, right? And we know this distance here. All right, and this it takes 36 minutes to travel this distance. The truck took 36 minutes to travel from this point to this point. So truck took 36 minutes to cover 3x over 5. That's the distance it covered in 36 minutes. After 36 minutes, they meet, right? Okay. Now, the car, it carried on, and it turned around immediately after reaching point A. So when the car, they met here, or at least they met here, and the car went on and turned around. In the meantime, the truck is just trudging along, happily at 1/4 the speed of the car. And the car goes and meets it again. It goes and it overtakes it. Right? If the car turned around immediately, how many minutes after meeting will the car pass the truck? So now we don't know how much the truck has traveled in that time. So from the meeting point to this is the second meeting point here. Right? So this is the first meeting point was here. Right? No, wait a minute. No, here, D. So let us assume that the truck traveled Y till the time they met again. Okay, so the truck traveled Y distance. The car at that period would have traveled 4 times that distance. So the car would have traveled 4Y. But how much did the car travel? The car went from this point it went across this. Here you got 3x over 5 plus x. It went up to that point and it doubled up, it turned around, right? Came back to the starting point, and it had to cover that distance that the truck had already traveled. So the car went there, x plus 3x over 5, and came back again. So that's double the distance. And it had to cover that 5y, which this truck had traveled. So the car in the meantime had traveled 2 times x plus 3x over 5 plus y. So now we can actually calculate y, because 4y minus y is 3y. And this here is x plus 3x over 5 is 5x over 5 plus 3x over 5 is 8x over 5 times 2 is 16x over 5. So y is 16x over 15. Right, so you got 3y is equal to that. So I'll have to divide by 3 on both sides. Okay. All right, so the question is now, after how many minutes after the meeting will the car pass the truck? Right? So it took, as I put down here, it took 36 minutes to cover 3x over 5. But now the truck is going to cover 16x over 15. That's why. Right? So the truck now, it would have covered 16x over 15 kilometers. You want to know how long did it take to cover that distance? This is when they will meet again. So this is a problem. If it took 36 minutes to cover 3x over 5, how long would it take? How much would it take to cover 16x over 15? So this again is a ratio problem. See, a lot of these problems are ratio problems, but it's so difficult to, or proportion problems. So but they come in disguises, so you can't really see what happens here. So to get back to this thing here, actually, you got, if it takes 36 minutes to travel 3x over 15, it has to be 16x over 15. This divided by that will be the question mark divided by 36 minutes. See? And then when you do this, you will get something. The x's actually cancel, because 16x divided by 3x over 5 is the same as 5 over 3x. So the x's go away. 5 goes into this 3 times. And then you're multiplying that by 36. So this divided with this, and then multiply that by 36. So you got 16 over 9 multiplied by 36. I think you're going to get 64. I'm not sure, but you can check this thing. But it's quite clear what you have to do. You have to, the answer is this. You have to find the question mark. Okay, so this is quite a difficult problem, and it took quite a long time to do. And you'll have to go over the recorded one to fully understand it. This is the kind of problem which will occur in round 3. Okay, I'm just going to see what else I've got here, because I'm running out of time. Let's see if I can do something quickly. Okay, there's your homework problem. Oh, I finished this. Oh, I'll put this twice. All right, so I don't have to do that. Assignment problem. You got an assignment problem here. Now this is what number? You have to check it out. I'm not sure what number this is, but it's in session 4. Okay. So look at your session 4 problems, and you'll see what number it is. But I'll put it down here so you can look at it on the screen and try to solve it, if you are going to read this thing again. All right, so that's your assignment problem. There's nothing more to discuss on that. And this problem here. Oh, this is the last problem. Yeah, this is the last problem. Let me just do this. If you need to go away, feel free to go away, but it'll take me maybe about 6 minutes to solve this problem. So those who want to stay behind, you're quite welcome to stay. Those who need to go, you can go, because I am overstepping my mark here. But this is the last problem. Southey noted that a train to Muizenberg took 8 minutes to pass her. Now, this is again a kind of a tricky problem. So let's see now. I'll take the first sentence and try to draw a diagram. And how do we do this? So there's a train. Oh, sorry. Okay, let me just do that. So there's a train here, going that direction, and Savitri is standing here, and this train is going towards Muizenberg. Muizenberg is some town in the Cape, it looks like. So it's moving towards M, and it took 12 minutes to pass her. I just want to jump to the end of this thing here. What was the length of the train to Musenberg? So you don't know what the length of this is. So let's just call this X. Right. So we don't know what X is, and that is the problem. Now it took 12 minutes. So when it passes here, it comes to this situation here. And that point which Savitri saw right in the beginning is now moved to that, right? So that point has moved through a distance y, because that's the length of the train. I'm sorry, what? X, right? So that point has moved through a distance x, right? So we can work out the speed. It took 9 minutes, you see. So we're working in minutes and meters. All right, so suppose we call this thing x meters. It's not kilometers per hour now, it's meters in the minutes. Those are your units. So it covers x meters in 9 minutes. The train to Musenberg. It covers x meters in 9 minutes. So therefore, in 1 minute, it'll cover x over 9 meters per minute. Now this is your speed, you see. Speed is distance over time. So this is the speed of, equal to the speed of the Musenberg train. All right. Now let's see. The other, then a train in the opposite direction to Cape Town took 12 minutes to pass it. So there's another train which is going, starting from here, but is going the other direction. And it reached this thing here. Given that the train to Cape Town was 150 meters long, so here we know how long this thing was. The Cape Town train, it's traveling to Cape Town. So again, we look at Savitri standing here, and the front of the train, it moves through a distance 150 meters. In how long? It took 12 minutes. So therefore, the Cape Town train, right, its speed is, as we had x over 9 here, it's going to be 150 over 12. Very similar. But it's taking 12 minutes now, and it travels 150 meters per minute. Right, so you got this, you got the speeds of the two trains. Now the question is, assuming each, the trains took 9 minutes to pass each other. Oh, this was supposed to be 8 minutes, sorry. It took 8 minutes to pass us, so this was 8 minutes. Right, this 8 was the Musenberg train. Now, it took 9 minutes to pass each other. Oh, so now there's another funny looking story here. So this Savitri is still standing here, and the one train goes this, and on the other track, you've got the Cape Town train. This guy is X meters long, and this guy is 150 meters long. And to pass each other, it means that this point went up to there, and here this thing came to this side, so they passed each other. So the total distance covered in that 9 minutes is 150 plus x, because you want to know how long did it take for them to reach this situation here. This traveled x this way, this traveled 150, so altogether it's 150 plus x. That's the distance, and divided by the time, and that is 9 minutes. No. So it took 9 minutes to pass each other. So in other words, the total distance covered was x plus 150, and that is a distance over speed, distance over, right, okay. The time, yeah, okay. So you got x plus 150, right. That thing divided by its speed, or the time that it takes. Now the one would have taken, in 1 minute, it would have taken x over 8. It would have traveled x over 8 meters. We saw 1 minute x over 8. And the other one, it would have, in 1 minute, it would have traveled 150 over 12. So, so this is the total distance it travels in 1 minute. And this is equal to 9 minutes to pass each other. See? So, yeah. Okay, so it's so yeah, here you have an equation involving x and in a simple equation involving x, and you can solve for x. Okay, I'm not going to do it. You'll know how to solve for this thing here, and that's the answer to the problem. So we gave a name to the length of the train to Muizenberg. That's your unknown, and you can solve for x, because once more we have an equation. The equation is obtained by calculating distance over speed is equal to time. So this is the speed, and that is equal to the time. All right. Okay. Thank you very much for listening, and we will meet again next week Monday. Today was quite a demanding one, because distance time problems are not easy. But please go over the recording will be available. Watch very carefully what I am doing, and try to get the ideas about how to solve these distance time problems. Okay, thank you very much for listening, and we're going to close up. But I'm just going to look at the chat group here. David, is there anything on the chat that I have to listen to?
No, there's no question in the chat.
So there are no questions in the chat, huh?
No, it's only those ratings.
Okay, thanks very much. Okay, guys, good night.